Hello, everyone. Thanks for joining us today. Today, we are going to cover the challenges in multi-cloud database management. We are going to talk about the challenges as well as we are going to get into a low-touch way to manage that using GitOps. So, joining me today is Sanjeev. So, I am Rajat Krishnan. I'm the co-founder of Cloud Control. And Sanjeev, please go ahead and introduce yourself.
Hello everyone, this is Sanjeev Kumar. I am heading the product development at Cloud Control. And today we will be covering the migration challenges for the databases into the cloud. Um, as the database is stateful all the time, and the databases has grown organically in the enterprises, the migrations run into the multiple challenges while kind of like creating a path to the cloud, and be it any cloud. So there are several kind of like we have listed here, and we will go into like the some details that what are those challenges, and uh, and I would like admit upfront that there is no one path which kind of like fits all. And later part of the discussion, we will go into some details that how um, we can create sort of like the automation template, we call it, so that any type of repeatable task uh, can be done like with full automation, and that gives us a better control over the migration and as well as the post migration the database management. So
Okay.
that is back to you.
All right, thanks, Sanjeev. So let's look at the 6 items here, right? So let's start one by one. So if you think about the today's enterprises and small businesses, anyone that is migrating databases to cloud, what do you think is the primary set of challenges? That's point number one here.
uh, I would say the primary challenge is that if they are planning to like, and again everyone is planning to move to the cloud, and that includes application and databases, the processes which exist today, they cannot bring the same set of processes into the cloud and think that they are in a kind of in a good place. And there are multiple reasons to that. Again, let me go into some the details here. And that the how they are managing the like the patching and upgrading planning they are doing. Of course, like some cloud providers have better what you call is the RDS services, and what sort of access control they need to give. That's another challenge. And I think the challenge they face is that their existing team, mostly the DBA Unix admin team, do they have to train on the cloud? So that's kind of like big uphill task. Like cloud itself is a it has done tons in the infrastructure automation space, and they have what they are presenting is infrastructure as code, but their existing staff is not up to the speed to to understand the entire the gamut of the cloud, how it operates, and from the networking aspect, from the day-to-day operation aspect. So that's the biggest challenge, kind of like any organization, small or large, face when they are trying to move to the cloud, and particularly the existing RDBMS.
And Sanjay, when it comes to selecting the right database solution, right? So, most of the on-prem are going to be Oracle or Sybase. When it comes to cloud, there are more options. They get support for more types of databases. So, what is your take on that?
That's correct. And I think let me first give you a bit kind of like the cost aspect of it, because in cloud everything is like uh, uh, like priced at an hourly base. So this RDBMS is priced certain dollar or like certain cents per hour, um, and people get tempted that it will be like they will be saving money in in the long run, but that may not be true all the time. And let me tell you that why. And this is an important factor which any organization has to like decide and before kind of like migrating the databases to cloud. So on-prem databases mostly have a kind of like the captive infrastructure. They are depreciating over several years, and it has certain price point. If you move to the cloud, you are mostly you are kind of like paying at a hourly basis, and if you are carrying the entire database, and in some cases your database may be 100 gigabyte. We have seen that, like you talked about, Rajit, you talked about the Oracle and Sybase databases. We have seen the terabyte databases and all. And if you take those databases as it is and try to establish in the cloud, your cost may be very high. So like let's take it that way. So if you are planning to migrate a large database, it is recommended not to go like for like. It will be costly, it will be unnecessary wastage, and it may not be kind of like good step in the right direction. And that leads to a second question: is that what are the options? Now, again, that's a separate kind of like the topic in itself, but I will give you a very high level that the options we have many options available in the cloud, and that kind of like gives us a better flexibility, and it does require some planning, and it may also require some kind of like the refactoring at the application level also, depending upon that how application is interacting with the database. But there are so many options available there. uh, One example I will give you that when we again, both of us come from the large financial services background, and when we built the application 20 years ago, there was no concept of an object store. So we used to store all the large files of different types into Oracle blobs or like equivalent one. Now we have the object store like Y2. So there are multiple options are available. NoSQL database was not as mature maybe 20 years ago. Now they are. So if we are planning to migrate a say terabyte of a database into a cloud, be it Oracle, Sybase, even SQL Server, there are it has to be kind of like thought through ground up, and it is the right time to think because it will offer the cost saving, it will have the less management aspect of it, and it's a kind of like the long term investment.
All right. So when it comes to migrating and using the right technology, we have a question here from Abhi. He's asking about, can we run containerized databases, right? So that is an option where, a lot of the companies are moving towards a Kubernetes kind of approach where containerized workloads can be managed and orchestrated. Now, running database as a container, is it an option?
That's a very good question, Abhi, and that is definitely an option. And I would say like this option is maturing day by day. So you name any RDBMS, and the RDBMS vendor itself have provided the, the images for that. It is available in the Docker Hub. So they can be run containerized. And Rohit, you know that we have a couple of production clients who are running the containerized databases. It is MSSQL, it is MariaDB, MySQL, and in fact, our platform itself we run containerized database. So yes, option is there, and that also brings a kind of like the very good segue. I would like to go there because the whole concept of the cloud is also offering to run kind of like the truly cloud native, the microservice based application. And it is the right time for monolithic applications to be broken down into a small components, and each component will have a kind of like a persistent layer which is suitable for that particular service. And that's what I'm talking about. So if you have a terabyte database and if you have a monolithic application, it is the right time to break down, have a combination of and once you break it down, then have a combination of like the NoSQL object store databases and the transactional RDBMS underneath, maybe running containerized. That's a very good option here, and kind of like the go live. So that's the strategy people should be thinking about.
And when it comes to running containerized, right? So one of the things that everyone talks about is when we go to a managed database, they give you the DR and HA and all that. So now, can we achieve the same in containerized databases?
That's a very good question, Rajit. And I would say that unfortunately, it is not widely available. So the vendors have definitely provided that, yeah, here is a Docker image for my say, MS SQL, or here is Docker image for say Oracle and like Postgres and all. But they, out of the box, what we see in the Docker repository, it's not available to run it in a kind of like the master slave model or offered kind of true HADR. That's one area. And again, as you know, we will discuss a little more about our company has invested, and we offer a HA and DR layer on top of most of the open source databases, and we offer kind of the master slave combination and the built-in the backup and DR capability. We have offered that. Uh, some of those things we had showcased in our previous like the demo, and we will continue doing that. So that's quite doable, and that is where kind of like the power of our like the app GS stack, which we will be discussing later, comes into the picture. That it is doable. Industry is moving in that direction, and in that process, like our company, Cloud Control, is making some development, and we will be discussing that in the second half.
And is there any cost benefit when we use containerized images that are kind of engineered with the DR and HA in it?
So apart from that, of course, you will have the HADR. You will have the like the resource consumption will be there appropriately. Maybe the multiple copies, and from the storage perspective, from the compute perspective, but otherwise no cost. Like and again, like one thing I would like to mention here is that this may be the right time to think about moving from a commercial database, which is like Oracle, MS SQL, and all, to an open source database as well. Because open source databases like the Postgres, MariaDB, so many NoSQL databases have matured enough, and with added resiliency and HADR capability, they offer a much better options for the modern application development and at a significantly low cost.
Awesome. Let's move on to the next next item, which is migrating ETL and reporting tools to cloud. What is your take on that?
That's like the yeah. So again, the databases, it's not that they're just a standalone. They have like the feeder processes, like so many SQL scripts, many ETL, like the data load and extract, like all those running on the kind of like on-prem data centers. So questions being asked like, how do we move those processes? Now, this is something that has to be kind of like carefully like looked into. Uh, the ETL vendors like have already like given their cloud version. That's one options to go to. The cloud providers have their own like ETL tools out there. Azure has Data Factory. AWS has, I believe, like it's called Glue. Yep, and so every cloud vendor has its own sort of ETL tools. You can embed them, but if you are already very much hardwired into your own ETL solutions, like Data Stage from IBM, I think it's called the InfoSphere these days. You can take them to the cloud. So they have the cloud version as well, and you can install them on a like the VM and manage it that way.
Okay. The third item here is change management. That's a big ticket item for most enterprises, right? Especially from the ticketing, the auditing, the audit trail, approvals, things like that. So how do we achieve that, and how can we improve the operational model around database change management?
Yes, and this is a very critical aspect, and I would say like very often ignored in like a small as well as large kind of like the companies. So the let's start with the beginning. What exactly is the change management we are talking about here? Um, as kind of like application changes are happening, they also incorporate some database changes, maybe a new table, maybe a new index, maybe a new like new column and all. And most of the RDBMS, and again, I'm talking about the traditional RDBMS like Oracle, SQL Server, Sybase, and all, uh, they have been very rigid about their structure. And that means is that if you change the structure of the table, then immediately the dependent objects may become invalid or will not compile. Again, that's another area where the NoSQL kind of like excels. Like they do not follow a very rigid structure, and applications can manage around that much better than what the SQL databases have to offer. Now, the SQL databases are best for the transactional, especially the asset transactions level. So now the change management is, I would say, like often ignored part because it depends upon that whose responsibility to make the change. And another like critical area is that the databases changes mostly go in the delta format. So it's not like a Java binary which you compile, and the next time you compile with additional changes, the all the previous changes and everything will be taken into account. Databases do not work exactly in that fashion because the database has as you know, that it's kind of like the change log and the incremental changes happening either at the structure level or at the data level. Now, some companies they offer that let their development team directly make changes in the database. It is very dangerous, and of course, this doesn't follow the norm of the regulated industries. If you are in the financial, healthcare, and other sectors, as per SOC compliance, this is an absolute no. Uh, Production environment should not have any developer access. At the most, they can read the data for troubleshooting, but no access to change the structure or the data. So now, how do you accomplish that the change management? And in fact, we have seen that many industries not even following the proper, I would say, the source code management, because that again, this is also in the Delta fashion how to manage that, and many companies struggle in this area. Uh, what we have done is that the first thing is that all the database changes, and for that matter, any changes, has to be source control. That's kind of like the given, so that we know that who made the changes, when was that made, and then we have to build a process that how that change can get applied. Um, we have seen some companies emerging in this area. Liquibase is definitely a leader in this area who are offering the database change management across multiple RDBMS. Flyway is another open source, and they also offer like very good way to kind of like handle the change management. And there are some other emerging companies in this area. What they offer is a kind of like an open source solution. Of course, they offer the support also, and to manage the database changes. And this is one area which we are going to show in our demo today, that how GitOps for change management can be applied against a Microsoft like SQL Server database. So that's later coming. We will be discussing some more details as we go along.
Awesome. So what you're saying is, the GitOps-based approach with the right tool can solve the change management challenges, right, in the cloud, right?
That's
So you
correct.
can keep track of who made the change, things like that, correct?
That's correct. That's correct. Yeah. In fact, one thing which I forgot to mention is that this becomes another critical area as the databases are moving to cloud. So, and as you move to the cloud, you have to reduce your surface area by all means, and who has access to the database, who can do what, because you are no longer within the four walls of your data center. So to reduce the surface area or attack area, you have to reduce that who can access the database, and unless you have a process built around, and that's what I was mentioning is that if you want to move to the cloud, whether application or database, rethink that you should not be bringing the same set of processes that you have within your four walls. You have to rethink from the security point of view. And again, we have some solution in that area where we allow only the break glass access, and everything else has to be fully automated and executed using the GitOps.
Right. So let's move on to the next item, HA and DR, another big ticket item.
Yep.
So, yeah, what's your take on that?
So I would say that, and again, I will put them into three different categories. Now, one category is that you just get a server and run your HADR the way you run right now in your own data center. Not an ideal situation because you are increasing your surface area, you are increasing attack surface area, and you are increasing your headache, and basically you are carrying your own processes into the cloud, which will be costly in the long run. The second option is to use the managed services, which many cloud providers offer. Like AWS has called the RDS services. So use their managed service. That means like they take care of the HA and DR. Of course, you have to design that in terms of like if you are multi-AG and multi-region enable, you do that so that a backup copy will be kept into a different region or different zone as per like AWS and Azure standards. So you have to follow those processes. And the third is that if you want to run the containerized, so it is the second area and the third area where you want to do the managed service. But again, to manage services, your infrastructure team have to be conversant in the cloud processes, like how to set it up correctly and all. So that brings the kind of like additional training challenge and make sure that the DBAs and Unix admin are conversant with the cloud processes and train them. And we have kind of like built a template based approach so that you just define your requirement, impose simple declarative syntax, and we will set up your database according to that requirement on any cloud. I will show you some the details on that. And the third option, we talk about the containerized database. So this is one area which is becoming more and more popular. And since this area is kind of like under full control, we have built a layer which is the backup resiliency and the HA layer on top of what is available in open source, and we are offering this as a service to run containerized database on the any Kubernetes cluster that you want that you have.
Okay. Number 5, we have security and privileged access management. So that is, again, it's important. I think a lot of folks, when they go to cloud, they, kind of think about it later once they kind of put everything in place. So this should not be an afterthought. You have to incorporate that into the process on day one. So what is your take on that?
Absolutely, yeah, and this cannot be a thought which can be like postponed for like the later because yeah, because if you don't do it right, you would be end up in a much bad shape, and in terms of the data leak and all sort of issues like the hack and all. So I would say like right out of the box, you start thinking about that where from the database can be accessed, and this is from the network perspective. The database has to always go into the private network. It should none of the ports should be exposed to the outside internet. That's the rule number one. The second is that who can access the database and from where. That also that nobody should be able to access the database directly from the internet or like again establish a bastion host, uh, establish a kind of like the break glass access so that kind of like on demand access. Yeah, like if people want to have access, they escalate their privilege to get access. So some of the things which I would like have already been in practice uh, at the enterprise layer, we have to bring that forward in the cloud database management also. And I think the foremost aspect is that try to automate as much as you can and try to have an audit trail that who is doing what. Again, do not give people blanket access to go there, and that is where why or like how the database gets accessed the maximum times manually. It is the database change management. So if you have build a automated process around that, then kind of like you have reduced your manual interactions to the databases to the maximum extent, because say that you're using managed databases, like you do not have access to the server, so that way you are definitely, you have some protection here. So if you also put kind of like automation around the change management, that kind of like reduces the manual interaction to the database to almost like 95%. So only the break glass and rare scenario you will be logged into the database manually.
And using GitOps also helps here, right? Because you can reduce the amount of time people spend directly in the with privileged access in the database, right? So can you
Absolutely,
touch on that?
absolutely. Yeah, yeah. And I would say that the GitOps should be, because whenever I talk about automation, uh, it is the GitOps. Basically, automation doesn't mean, so let me just clarify, because some people think that automation means that I write a script and then I manually execute it. Then the whole purpose is defeated, because you can change the script. So we just cannot rely on that process. That if you want to run that script has to be first checked into the Git, and that script has to be executed from Git via some process. And of course, as you see, our process, like our platform will be discussing, we offer a GitOps engine to execute your script and have the full audit trails. Also, kind of like embed the workflow, means like the approval, like workflow in the process, to show that somebody wants to execute a script, uh, and who approved that script to be executed, and once the script got executed, what are the outcomes, and full audit trails. Like everything has to be tracked. Then only we have the true audit trail around the, like what is changing in the database and who else is accessing the database apart from the application.
Okay. So let's move on to the last item, and then we'll go into some Q&A. We have several questions waiting. So I know we touched a little bit on audit and compliance. I know, as you mentioned earlier, the GitOps option will definitely help. Can you elaborate on that, and what is that one need to keep in mind when it comes to audit and compliance?
Yeah, and one thing I forgot to mention is that, and when it talk about the GitOps, people start immediately thinking that if an automated process is going to execute, how will that process kind of like assume my credential or my role? That's a big question. And unfortunately, like I have to admit that I have reviewed many private GitHub repository, lot of scripts out there, and people's secrets are also out there. Again, this is a complete no. So the secret just cannot go into the Git, even if it's private repository. So make it a practice that you will never enter secret, and that secret may include the AWS credential, the database credential into Git. That is not GitOps. If you are following that, then kind of like the whole GitOps purpose is defeated. Then what is the alternative? So you have to use some kind of like the secret manager integration. Our platform offers the HashiCorp Vault, which comes built in as part of the platform. So you store all the secrets in the vault, and only uh, and the vault will release the secrets to the GitOps process at the runtime. That is how it should be architected. So you have to, and again, as you are moving to the cloud, the security should be forefront in your mind, and how to enable the security, how to operate in a secure way. That should be your kind of the first priority. And once you do that, and once you have kind of like the audit trail, then you have the full visibility that who is doing what, who approved what to be done, and what are the post outcome. That way you can have the full visibility that any change happening in the database, from the structure point of view, from the configuration point of view, from the like the data management and the storage point of view, everything is visible and auditable.
Okay, so let's take some questions.
So
So Bibin is asking, again, I think we kind of covered this, but it'll be great to summarize, let's say, the top 3 or 5 items that we need to keep in mind to secure a cloud, a database in the cloud.
So I would say that make sure that database is not accessible from the outside directly over the internet. That's the first. The second would be that never put your database secrets in the GitHub repository. And the third would be that build a process which logs any change apart from application, because application will be mostly interacting with the data. But any change which is happening in the database, and howsoever you are managing the database, containerized or like a managed database service, or kind of like you're building your own server and running it. Any change happening on the database has to be logged and visible for audit purpose. So these three will definitely make your database secure.
Awesome. So let's move on to the next question. Sharad is asking, I think we spoke about, so many different options to make, achieve or kind of achieve what you want in the database within the cloud. So the question is, the same rules apply to containerized databases as well? And can they achieve all those goals as well?
I would say yes. And one thing I would like to add, that if you are running the database containerized, to some extent they are safe, because yeah, they're running behind a, like in the cluster, and they are following the similar type of construct which your applications are following. So yes, the options are not right available out of the box from the Docker images which is out there, but our platform, AppG platform, have enabled like resiliency, HA, and the DR capabilities for the containerized databases, and that's what we will be doing a demo also today on one of the databases.
Okay. The next question, rollback. I don't think we touched today. So I've been asking about a rollback. So can you touch on that?
Yeah, so rollback is a like big topic. I'll just give a very high level overview, and and let's talk about the rollback in terms of the database change deployment. And I definitely give kudos to the Liquibase, and Liquibase has a very good rollback capabilities, because what they do is that as the change, and you will see that in action also, as the changes are getting deployed, they are taking a snapshot of the changes and keeping it in their repository, kind of like they are managing the state of the changes. So they offer the rollback capability also, but I would still say that this is a emerging capability. Liquibase has definitely made some offering, but the one thing you have to remember is that if you applied some change, and that was a structural change, is say yesterday, and by today the more data has come in, so the state of the database has itself changed. So if you roll back a change, there may not be the exact same thing that you will kind of like get. So you have to be aware of that. So this is something which, yeah, some of the tools are offer that, and we have built how to execute upon that. But you have to be cognizant of the fact that you should know what you are doing before you do the rollback.
Awesome. So let's move on to the demo. So today we are going to show, Liquibase triggered through GitOps. So can you kind of explain the setup that we have and our platform a little bit?
That's correct. So what we are going to show today, that our AppG platform, which is built on the 3-node EC2 instances on AWS, and this is a running the microcade Kubernetes cluster, and we will show you a SQL Server 2017 running containerized on the AppG platform, which is represented here as the Kubernetes cluster. Now, this SQL Server like could have been running as a RDS in AWS or Azure. It doesn't matter. But for demo purposes, we are running it containerized. And then we are going to show you that against that SQL Server, we are going to apply certain changes, some table creation, some data insertion using the GitOps. So what Rajit will show that he will be wearing the developer's hat, and he will have access to a Git repo. I have made him collaborator in my repository, and he will commit a change, and that change will get picked up by our AppG platform, which you see in the middle, uh, and it has the GitOps engine built in. This change, which Rajit will commit, those SQL changes will get merged with AppG stacks, which is the Liquibase image, and those together will get built and deployed on the SQL Server's instance, which is running on the Kubernetes cluster, which is kind of like the part of the AppG platform itself. And
Okay.
yeah,
So let's start the demo, right? So let me share my screen. So I'm going to start with the dashboard. So this is our AppZ dashboard. So Sanjeev, you want to take us through what is running here in this cluster?
That's correct. So as you can see that if you scroll down, Rajit, like there's a vault running. So any cluster we deploy, or any in this case you can see that we have a context called as Kumar Pi dev. In that context, we have the first component that we deploy is vault. That vault is keeping all the secrets within that context. So the secrets would be for the workload related to MS SQL, or if the Liquibase is using some secrets to deploy the change on the MSSQL database. So the vault is the first, I would say, workload gets deployed for keeping the secrets. The next workload that we have deployed is the MSSQL 2017 itself, and that is running containerized database. And Rajit, if you can show that containerized database using your visualization tool, that would be great, so that people can see.
Okay. So this is the database, right? So yeah, please walk us through this.
Yeah, so as you can see that this is a MS SQL database, and the DB visualizer is the database browsing tool. You can see that there is a cloud control database that has been created, and there is no table right now in the database. So it's an empty database, empty cloud control database running on a MS SQL 2017 containerized.
All right. So basically that we connected to this instance here running in the cluster, right?
That's correct. That's
okay.
Correct. Yep.
All right. So where do we go next?
So let's go to the GitHub repository now, where we have the Liquibase. Now this now let's show the SQL scripts, Rajat.
Scripts, yeah.
Yeah. So as a database developer, I have these 4 SQL scripts. As you can see that 3 of them are table creation, and the 4th script, jobs insert, is inserting some data into the jobs table. So these are the 4 SQL scripts, and as part of my development, I want to deploy these SQL changes onto the database. Now, this database could be running containerized, or like running like managed services. It doesn't matter. They are the SQL changes which I'm going to deploy, and what we are going to show you that how this change via GitOps gets deployed, in this case on the containerized database that we just shared with you.
All right. So can I go to
So let's quickly explain the AppGML. Then we will explain the. So this AppGML, as you can think of, is a way to integrate the end users GitHub repository with the AppG platform. So this is kind of like a standard. We have several videos out there which talks about that how to deploy a Tomcat application, a Spring Boot application, by simply injecting an AppG YAML, which defines the GitOps process for that repository to get deployed against the target infrastructure. Target infrastructure could be a Kubernetes cluster. The target infrastructure could be the cloud itself, where you are configuring the cloud to meet your requirement. So in this case, the target infrastructure is the SQL Server instance, which is running on the AppG platform Kubernetes cluster. And if you look at the image template, this is the AppG stacks we talked about earlier, and this is a Docker image which is built upon the Liquibase open source project, and we have layered the logging and the monitoring capability on top of that. That is how you are able to see that how the changes are getting deployed from the AppG dashboard. So like I think with this introduction that by just simply injecting an AppG YAML into a database repository, this database repository is ready for the GitOps via webhooks. So Rajit, you can just simply show the webhooks like how that is enabled, and then we will. I think you don't have access to that.
Yeah, I might not have access to do
Okay,
that.
so
So before we go there, right? So I would like to highlight this. Can you
yes.
touch on the vault part of it, please?
That's correct. That's correct. So as you can see that the change deployment will go against the MSSQL 2017-2, which is a containerized database running on the cluster, and the change will happen against the database name called Cloud Control by the user AppG user, and this user's password will be retrieved from Vault, which I discussed with you that Vault is already running on the platform at runtime, and we will show you as part of how the vault password is getting retrieved and the change getting deployed.
Okay, so let's move on to the root of the project.
Yep, and let's look into the DB change.xml. Let's go there. So again, this is the Liquibase technology here in action, and this is where the developers need to put the details that what change they want to get deployed. And as you saw, there are 4 scripts. We can execute 1, we can execute 2, we can execute all. So Rajit, go ahead and make the changes. And
I'm pasting one change set at a time, so you can explain.
Yep. So what we are doing here is that the first change, which is going to create a person table, that we are going to deploy on the database. So you can commit, Rajat.
So you want to commit now, or you want to add all of them?
It's up to you. I think how much time we have. So I think why don't we add everything together? Then then we will commit it, because that way we have more time to explain the whole GitOps process. So we have added 4 set of changes here: the create persons.sql, create customers.sql, create jobs.sql, and job insert.sql. We will show you all these files also. So these change sets have been added. The syntax for that you see is the standard. The Liquibase also offer like different other type of syntax as well, and depending upon the requirement, we can work with the customer to make sure that whatever way they want to, whatever way is suitable for the development team, they can adopt that. So reach out to us if you want this change deployment to be implemented for your organization. So with this, let's commit the changes, Rajit. Can we go to the dashboard now?
Yeah.
So as you can see that the change has been picked up by our GitOps engine. So let's look into some details here.
So I'm refreshing again. So it is.
So what is happening here, and as I discussed earlier in the GitOps process, that the changes from the Git repository, in this case, those 4 SQL files and that XML file, those are getting picked up and merged with the Liquibase stacks, which is getting pulled from the repository. And those 2 stacks are merging, and we build another image which gets pushed to our Docker registry, and that image is getting deployed against the target database. So we are using the innovative technology of the Docker Kubernetes to capture the change also and deploy it against the target infrastructure. That way, the change itself is an immutable like image that we built it, so that that can be tracked anytime. Although the target infrastructure may be somewhere else, but the change itself is completely immutable, coming out of the GitHub and getting merged with the our image template, and then getting deployed against the target infrastructure. So Rajit, can you show the deployment part also? I want to show the, the Vault integration. So as you can see that the Vault is supplying the secret here, and then all the changes get merged and we have the deployment YAML complete. In fact, we follow whether we are deploying an application or we are deploying a database, we follow the exact same process. So if this is an application, this will get deployed on the target cluster itself. And in this case, the target infrastructure here is the SQL server running a containerized and the change getting deployed. So Rajit, we can look at some of the logs and as well as that we show the real. So as
So,
you can see, the Liquibase update has been successful. So this message shows that all the changes which we were targeting as part of deployment has been completed. So we have a verbose option also. If we enable that, then we will all the details will come here as well. So let's refresh the data here. Yeah, as we can see that 1, 2, 3, the three tables and have been created. If you look the jobs table, we are inserting the data also. Can we look at the jobs table, the data? Yep, we can see that this data. Now, Rajit, you can show the repository also so that we can show that, yeah, exact same thing that we have brought here. Then we will discuss the.
so you want to go here and go into this
Yep.
and jobs insert, right?
Job insert, yeah. So this is the data we wanted to insert after the table creation and the exact same thing that has happened. So the idea here is that, yep, this is a simple, like a few table creation, some data insertion, and everything is happening through the GitOps process. Nobody logs into the database server. What you saw is more for a kind of like the browser, like a read access, you can see that. But for a production database, the changes are getting deployed in a fully audit and like auditable way and uh, without any privileged access. So that was the idea to show the database change deployment. Now this change deployment we have available on against all RDBMS platform, whether Oracle, like the Sybase, the DB2, Postgres, like the or you name the RDBMS, we have the change deployment mechanism using the Liquibase and also using the Flyway to support that.
Awesome. So that was a good demo. So anything else you want to add as a summary, Sanjeev?
Yeah, what I would like to say is more to tell more about our approach. So Rajit, why don't you share the deck and we will show that what type of stacks we have, because that is something which we would like to mention here. Uh, what you see here is either the foundational stack to build the application, and that you see mostly around the like the web services and the middleware tools. And then under the databases, as you can see that we can run all these databases containerized. And if you look at the database ops on the right hand side, right bottom, uh, any kind of like the change management, any kind of like we also have some migration stack also. So if you're thinking to our like re-platform database, so on-prem you are using Oracle, but if you want to go to the cloud, as I discussed earlier, I think the best option right now is the move to Postgres for the transactional database, transactional purpose, and start using the other sources, some non-SQL databases, and also the object store to have a kind of like the varied and most cost effective and the resilient database out there. And that way, like once you move to the cloud, you have better security, better cost structure, and kind of like better TCO all around. That is what you want to achieve by moving to the cloud. And as you can see that we have several stacks, and this is not the complete list that we have here. We can build the custom stacks and kind of like meet your requirement uh, after reviewing your what you exactly you are looking for. And I think that summarizes that the way we kind of like the create the automation template and make it executable in the fully controlled way is our unique offering from the Cloud Control AppG platform.
Okay. And can we also look at the cluster that we were running and how we built it? Um,
That's really a good thing. So like what we saw today, the dashboard is going against a 3-node EC2 instances uh, against our AppG platform. Our platform runs on a 3-node Kubernetes cluster, one master node and two worker node, as you can see here. The dashboard was pointing to the master node instance, and the webhook URL is going against our AppG platform engine. And the workload, as you can see, that there are several workload here. Uh, if you watch our previous videos, go to the Cloud Control and subscribe to our channel. There are several like videos out there which talks about other application deployment like the Spring Boot and the WordPress. Now, in this case, what we deployed here, we had a running MS SQL Server instance on one of the worker node, and then we deployed a Liquibase image that must have been running on one of the worker node, and that interacted with the MS SQL containerized database and apply the changes. So that is how we orchestrate, and as you can see that everything is done from in a true GitOps way, fully auditable, uh, the secret management involved, and the all the like the audit trail is visible through the log. So that's kind of the platform, the Lotus platform that we like. Lotus Cloud platform that we bring for our customers. And if you are struggling with the database migration or change management, reach out to us.
Thanks, Sanjeev. That was a good demo, good session. And thanks everyone for joining. Please do check us out in LinkedIn as well as in YouTube. So we have several other videos, especially the how we build the cluster and how we deployed other workloads. You'll be able to see them in several videos in our YouTube channel. And also, please stay tuned. We will be going live every week at least once with different types of images. Today, as you can see, we were featuring the Liquibase image. And coming weeks, we'll be featuring different images in a GitOps model. Thanks, everyone. Thank you.
Thank you.